Welcome to today's physics class. Today's class is the continuation of our last class, which is on moment of a force. In our last class, we stopped at looking at some examples. So today, we will continue from where we stopped. Now let's look at this example. A uniform beam 6 meters long, weighing 5 kg, rests on support P and Q, placed left and right 1 meter from each end of the beam. Weight of mass 10 kg and 8 kg are placed near P and Q, one on each end of the beam. Calculate the reaction at P and Q. Now we have what? A uniform beam. Now, because the beam is uniform, the weight will be at the middle. Weight is 5 kg. Now, we're told that support P and Q are placed 1 meter from each end. This is support P, 1 meter. The weight is at 3 meters. And this is support Q, which is also 1 meter from the end. Now, mass of 10 kg and 8 kg are placed near P and Q. So we have a mass of 10 kg, and here we have a mass of 8 kg. Now, the first thing that I want you to know is that each of the support will create what? A reaction. Each of the support will create a reaction because actions and reactions are equal and opposite. In this case, the masses 10 kg, 5 kg, 8 kg are the what? Action. Why the reaction P and Q will be the reaction. So since the actions are coming down, the reactions will go what? Up. So we convert what now? Every mass to weight. So we will have a weight of 10 kg is 100 Newton. So when you multiply 10 times 10, now reaction here will be reaction P. And you know that this is what? 1 meter. The weight 5 times 10, that will be 50 Newton. This is 3 meters. Then we have a reaction Q here. Reaction Q. And if we start numbering from left to right, this is 1 meter, this is 3 meters. Now, you know that this is 1 meter from the end. Reaction Q is 1 meter from the end. From the right, which will be 5 meters from what? From the left. So I will put what? 5 meters from the left, meaning 1 meter from the right. So 8 kg will be what? 80 Newton. Now, if you look at this system, the system have parallel coplanar forces. What does that imply? It means that the sum of the forces going up will be equal to the sum of the forces coming down if the system must be what? In equilibrium. So how do we write that? We have reaction P plus reaction Q will be equal to 100 plus 50 plus 8. So we are going to now have reaction P plus reaction Q that will be equals to 230. So now, let's look at, so that's the first condition for equilibrium. Now let's take moment. Now because we have two unknown, Rp and Rq, for us to simplify our expression, we can take moment at Rp or Rq. If we take moment at Rq, the moment of Rq becomes 0. If we take moment at Rp, the moment of Rp become what? 0. So let's take moment at what? Rp. So we can say taking moment at the reaction Rp. Now if we take moment at Rp, now you know this, the first 100 Newton will drag it along its direction towards where we are taking moment, which means with the knife edge is now at Rp. That's what it means. It means the knife edge, since that's where we are taking what? Our moment. So if you drag 100 Newton towards what? Rp, that will be what? Anti-clockwise. If you drag 50 Newton towards Rp, that will be what? Clockwise. If you drag Rq towards the knife edge now, that will be what? Anti-clockwise. If you drag 80 Newton towards the knife edge, that will be what? Clockwise. So we can say that the 50 Newton force and the 80 Newton force create what? Clockwise moment. While Rq create what? Anti-clockwise, and 100 Newton create what? Anti-clockwise. So now let's go. Let's look at first of all our clockwise moment. Let's look at our clockwise moment. No, we said that the 80 Newton force create clockwise moment and the 50 Newton create clockwise moment. Now, from this knife edge is at 1 meter from the left. So the distance between the 80 Newton force and the knife edge will be what? 5. So moment is force times perpendicular distance. So that's for the 80 Newton. Now for the 50 Newton force, you know the knife edge now is at 1 meter and the 50 Newton force is at 3 meters. So the distance between 1 meter and 3 meters is what? 2 meters. So that will be force 50 times the perpendicular distance, which is 2. So that will give us 80 times 5, that's 400, plus 50 times 2, that is 100. That will give us 500 Newton. So that's clockwise moment. Now let's go to the anti-clockwise moment. Now, anti-clockwise moment, the 100 Newton force is at a distance of 1 meter from the knife edge. That will just be 100 times 1 plus Rq. This is 5 meter from the left and the knife edge is 1 meter. So 5 to 1, that is 4. So that will be Rq times 4, which will give us 100 plus 4Rq. So for moment, according to the principle of moment, the clockwise moment must be equal to the anti-clockwise moment at a point. So we are going to have 100 plus 4Rq is equals to 500. So which means 4Rq will be equals to 500 minus 100. That will give me 400. So divide both sides by 4. we will be having RQ to be equals to 100 Newton. Now remember our equation 1 that RP plus RQ is equals to 230. Equation 1. So now that we know that RQ is 100, that will be 100 plus RQ, that will be 230. So RQ will be 230 minus 100. So RQ will be 130 Newton. So, sorry, this is not RQ, this is RP. RP will be 130. So let's go. RP, RQ, what will it be? RP is what? 130 Newton and RQ is 100 Newton. So that will be 130, what? 100. Alright, let's look at another example. A pole AB of height 10 meter and with 800 Newton has a center of gravity 4 meter from the end A. Now because the pole is not uniform, so the weight will not be at the middle. So we're given the weight is at 4 meter from the end A and lies on a horizontal graph. The end B is to be lifted by a force applied at B. The least force required to do this is, now let's go, we have a pole A, B, that is what? 10 meter. The weight of the pole from A is 800 Newton. This is 4 meter according to the question. Now we need to lift this place. No, lift the edge B up. Now the first lifting it up must go what? Up. So is a what? A reaction. Let me call it reaction B. Since the weight is an action. Now, what do we do? How do we get this force? Now, if we take moment at B, arrow B will not create a moment. So the best thing to do is to take moment at what? At A. So let's take moment at the point A. If I'm taking moment at the point A, which means I have my ninth edge at what? Point A. So which means from A to the 800 Newton is 4 meter. And from the 800 Newton to B is what? 6. This is 6 meters. So now if you drag RP in the direction to the ninth edge, you can see the way it's moving. That's what? Anti-clockwise. If you drag the 800 Newton to the direction of the clockwise, you can see the movement. That is what? Clockwise. So clockwise moment will be equals to 800 times the distance, which is 4. Anti-clockwise moment will be, now the distance from RB to the ninth edge is 10, so that will be what? 10 RB. Anti-clockwise moment must be equal to what? Anti-clockwise moment. So we can write 10 RB is 800 times 4. So RB will be 800 times 4 over 10. That will be 320 Newton. So the least force that must be applied at the end B to lift the pole is 320.